In this example, we're asked a lot of different parts to this. We want to identify each critical point as a local max, local min, or neither, and we also want to be looking at inflection points and maybe even graph it. We'll probably do the graph it on Desmos to see. But I've done some work already, and so feel free to pause and see if you get the same thing. That f prime is going to be 3x squared minus 12, and then we factor it, and so we end up having x equals negative 2 and 2 as our critical points, and we want to know whether or not it is positive, f prime is positive or negative. So for this one, we could actually do the first derivative test and look on either side of what is going on. This one, I might actually do the second derivative test. This one really would be a personal preference. One is not going to be extremely worse than the other. So I'm going to use our second derivative test, and we end up getting 6x. And so here we get f double prime of negative 2 is negative 12. Did I care about it being negative 12? No, I cared that it was negative. So that means we are concave down, that f is concave down. So we have a local max. F double prime of 2 is 12. That means f double prime is positive, f is concave up, so we have a local min. So for our critical points, I'm just going to look at the x values right now, and for our critical points, and so I'll call it critical numbers, we have x equals negative 2. What did we say at a negative 2? We got a local max. And at x equals positive 2, we got a local min. Since we knew we were going to have to take the second derivative because we were asked about inflection points, that was another reason why I went ahead and did the second derivative test for the critical numbers. We already have f double prime equals 6x. So we see that this, by looking at when we're going to change from positive to negative, how we find that is to try and find, are there any spots where we have breaks in it? No, 6x is defined for all x's. The only place we can change from positive to negative is by going through 0. So we see that x equals 0 is a possible inflection point. And if we look at f double prime, we change from negative to positive. So f is concave, goes from concave down to concave up. So that tells us 0, 8, this is an inflection point. And we can sketch this, especially once we have the full critical points. We can sketch these, give pretty rough sketches. The fact that we have a local max and a local min, and then we have an inflection point at 0, 8. And then we can see that if we go to Desmos, we get very similar to our sketch.